Hi guys, this is Edward, and welcome to the fourth video of creating a Flappy build game with Godot. So in the previous video we took care of the spawning, so now in this one we are going to be working on the bird. We're gonna make it react when it hits something, and also kind of make it wait until we actually begin the gameplay, because the game starts right when this scene shows, and that doesn't feel very good. And to do so we're going to use Finite State Machine. So I'll go a little bit off from our project to explain what Finite State Machine are. And I don't really want to explain it with theory, but with an example. So we have here this square that represents a character. And this character has three simple states. Idle, which is when the character is doing nothing. Running for when it moves. And jumping for when it is, of course, jumping. So the idea of the Finite State Machine is that this character can only be in one state at a time. And each state has a transition to another one. And the states and the transitions are going to be defined by us. And for this simple character, this is how I have set up the states. So the character is now in idle. And this state has two transitions out. One goes to jumping and the other to running. Now, because of the way I have this set up, in order to go from idle to jumping, I need to press space. And once I do, you'll go back to idle when it's grounded. And to go from idle to running, the left or right keys has to be pressed. And it's going to return to idle when these keys are released. So the benefits of using a Finite State Machine is that they help us to have a very clear code. Because while we are in idle, we just have to take care of the idle state code, like playing a few animation and checking if we press any of these keys. And in the running state code, we just need to worry about moving the character. And the same goes for when it's jumping. Now, I don't want this video to be about explaining Finite State Machines, but about implementing it in the project. So I'll leave a link in the description on an article that already explained that really well. And it's from when I learned about state machines for the first time, and I haven't had the need of looking more information about it. So if you're interested in the benefits of using a state, check it out. Now for the bird, this is how we're going to implement the state machine. We will have 4 states. The first one is the flying state, which is kind of like the waiting to start the gameplay, because in this state, the bird is going to be flying by itself without falling. And also notice that there aren't any pipes being spawned, so yeah, we'll have to do that too. So to go to the next stage, the gameplay has to start, and this is actually just a button in the middle of the screen telling us to tap. And once we start the gameplay, we will go to the flying state, which is basically when we give to the player the control of the bird, and the pipes start showing up as well. Now when we are flapping and we hit a pipe, we will go to the hit state, which will disable the ability to flap, making the bird falling, and when the bird hits the ground, we will go to the grounded state, which is what is going to let us know that it's time to show the score and all that. And finally, it could happen that the bird hits the ground without hitting a pipe, so we can go from flapping to grounded. Now just before jumping into the editor, we have to keep in mind that the computer doesn't know about this flowchart or any of this logic. So I can say that when the bird is in hit state and it hits the ground, it has to go to the flapping state, or when we press the down arrow key, we will set the state to flying no matter in which state it is. So what I am trying to say is that this is just an idea for us of what we want to accomplish, and there is actually nothing holding us from being in the hit state and set it back to flapping. Although I don't know why we will do it, but we can do it if we want to. Now back to the editor in the bird script. We're going to create 4 classes that are going to represent our states. So we will have the class flying state. And on state, everything we want to do, we will probably want to do it when the state has just been set. And for that, we have the init callback, which gets called when an object of this class has just been created. And we also want an update function with the delta time for frame by frame actions. And last but not least, an exit function so we know when it is the end of the state. and we can perform some actions before going to another state. And I have also found that it's very common to handle inputs within a state. So let's also have an input function with the event that has happened. And for the other state, we also want the same. So I'll copy and paste these 3 times. I'll rename the second one Flappy state. This one hit state. And the last one grounded state. By the way, you can also have a class named birthState and extend these classes from it. But since GDScript is a dynamically typed language, it will only care about the variable containing these functions. And since these are just 4 simple classes, I don't really see a point in complicating it that much. So now that we have defined the states, in the var, we'll declare a variable named state, and we will set it equals to a new instance of the flying state. And that will automatically run the init function, so you can see it as a constructor of the class. Now we probably will be performing some actions with nodes in the init function, so I'll type the keyword onReady, so the variable gets assigned when the var node is ready to go. Now we have written some code in here, but since we are now using states, we want to delegate other actions to the stage that is currently running. So all this code is to make the bell flap. So we will move all this to the flapping state. We assign the linear velocity in the ready function. So we will do it now in the init function. The code in fixed process we will have it in update. For the flap function, since this is something that only happens in the flapping state, I'll move it there as well. And of course, we just care about the flap action in the flapping state. So now that we have cleaned this, the fixed process function will delegate it to the update function of the current state, passing of course the delta time. And the same for the input callback. And we won't be calling the init function because this is a callback that gets called when we instantiate an object with new. Let's make the var start with the flapping state so we can see if it is working. And it throws us an error, telling us that the resends a function gets linear velocity in base reference. And this actually makes a lot of sense, because even though we are in the var script, this code here is in the flapping state class scope, so we don't have a direct access to the var. Now what we can do is ask for the var in the init callback, have a member variable that saves a reference, and assign it right here in the init function, using self.var because they both have the same name. So now we can set the linear velocity using the var reference, as well as getting the velocity. And the same goes for getting the rotation, setting it, setting the angular velocity, and the same for every time we want to call a function that is in the var itself. So since we are now asking for a var reference in init, when we create a new instance we will pass the var itself. Let's give it a shot. And we have the var just working as before. So since a reference of the var is something that we do want to have on a state, we'll grab a reference just like we did in here in the other state classes. Now every time we want to set a new state, we have to assign a new instance of the class of that state, which is totally okay. But I want to simplify this in a way that other scripts don't even have to know about creating a new instance or how we have this set up. So we're going to create a function named setState with newState as a parameter. And the new state won't be an instance of one of these classes because that will be missing the whole point of this. But it will be an identifier for one of the states, which we are going to declare here as a member constant. And I'll name them state flying, state flapping, state hit, and state grounded. And it doesn't really matter what we set them equals to, as long as they are all different. So now in the setState function, the first thing we will do is call the exit function of the current state. So we're letting it know that it will be not longer the run state, and it can do whatever it needs to. And after that is when we actually are going to set the new state. So we will ask if new state is equals to state flying, and if it's so, we'll set state equals to flying state that's new. And let's not forget to pass a reference of the bird itself to the new instance. And if it's not equal to state flying, we'll ask if it is equal to state flapping. And if it's so, we'll set it to a new flapping state. And the same for the other states. So since we are setting the state by using these identifiers, we should also get an identifier when we ask for the current state. So we will ask if the state extends the flying state class. So by doing this, we are asking if the state is an instance of the flying state. And it will be the same for the other states. So before doing the logic of the other states, let's take care of the animations. So let's go to the 2D view and click on the animation player node. And here we have the animation editor. Let's create a new animation named Flap. And since all the animations are going to be really fast, I'll set the speed to 3, which won't only affect the flap animation, but all the animation we create in this node. So in the animated sprite, we'll create a key for the frame property, and it is asking us if we want to create a new track for this property. I will hit create, and we can see with more details what this key is doing by selecting it and clicking on this icon here, which will open this panel, telling us that this key is in time 0 and it's setting the value to 0. So we're going to move to time 0.2 and add a key with the value of 1. Let's move to time 0.4 and add a key with the value of 2. And finally, in the time 0.6, we will add a key with the value of 0 again. So in this animation, the bird does a flap and returns back to its normal sprite. And since the last key of this animation is in time 0.6, I'll set the length to 0.6, so we don't have extra time in the animation. Let's now do the flying animation. And on this one we're going to move the sprite up and down. So I'll add a track for the position. And at 1 second I'll set the position to 6 in the y-axis. And I'm also going to set the length to 1.5 seconds. And since this animation is going to be happening over and over, I will enable looping by toggling this button here. And we also want to change the frame of the sprite, so let's add a new track for the frame property. And at 0.7 we'll set it to 1. At 1 second we'll set it to 2. And at 1.3 set it back to 0. And there we have it. Finally, we're going to make the idle animation. And this one is just going to set the frame of the animated sprite back to 0. And the sprite position back to 0 as well. And let's give it a length of 0.1 seconds. And also enable the autoplay on load. So this is the one that plays when the bird is created. So now in the flapping state, every time we flap, we'll get the anim node and play the animation flap. Let's try it out. And now we have the bird flapping. Let's now take care of the flying state, which is the one the bird is going to start with. So let's set the state equals to flying state. And don't forget to pass a reference of the bird. And if we run the project, the bird just falls and we can't flap by pressing space, which is good. So the first thing we will do in the flying state is get the noAnim and play the flying animation. And of course this doesn't prevent the bird from falling. So I'm going to set the gravity scale of the bird to 0. And without gravity the bird is not falling anymore. Now we just want no gravity while the bird is flying. So we'll have to set it back to the scale it came with. So I'll declare a variable named previous gravity scale. And before setting the gravity scale to 0, we will save its value in this variable. So now when the bird exits this state, we will set the gravity scale back to its previous value. And we also want the bird to go right while it's flying. So just like in the flapping state, we will set the x velocity to 50 without affecting the vertical velocity. Now I don't mind having a magic number once, because in this case it's pretty obvious what it means. But since we now have it twice, it's time to have it on a variable. So in the var let's declare a variable speed equals to 50. So here we'll say instead var.speed. And here as well. Let's run the project, and there we have it. But the problem is that the spawner pipe starts spawning as soon as the scene begins. So for now in the spawner pipe, let's create a function named start, which is going to do what it's doing in the ready function. And that is, go to the initial position and spawn and move as many times as the amount of field view. Let's run it again. And now we don't have the pipes in our way. So now we need a way to go from flying to flapping. And for that we'll use a button. So in the game stage, let's add a texture button. And for the normal texture, we will assign the instructions sprite. So since we don't want to force the player to press exactly on this sprite, I'll set the size of this button to the size of the game view. So that will be 144:256. Now the problem is that the sprite is staying at the top left of the button. And we don't have an option to change it. So I'm going to remove the sprite and add a texture frame in the button node. And here we will have the instructions sprite. And we want the texture to be in the middle of the view. So I'll set its position to have the game view, 144 divided by 2 and 256 divided by 2. And we have the top left corner in the middle of the view. And unfortunately there is no way to change the origin. So for the x position I'm going to extract half of the width. And for y, half of the height. I'm going to rename the button to btn instructions. And the texture frame to just texture. And let's run the project to see what we got so far. And the button doesn't stay put in the view. So we just have to do the same we did with the background. And that is use a canvas layer. So let's add a canvas layer. And set the button as a child of it. And make sure that the layer is set to 1. So it gets run on top of everything else. Let's give it a shot. And there we have it. I will rename the canvas layer to HUD, which stands for Headshot Display. So now let's add a script to the button. Now this script is going to be a built-in resource, which means that the script is going to be saved inside the scene file. So we won't have a GD file for this script. Now I only use built-in scripts for user interface logic because they are usually quite silly. And the way I see it, when it comes to games, for the user interface you will have either one big script that handles everything, or different scripts taking care of specific actions. I'll go for the second option and have several scripts. And since Godot allows me to have them without having all those files, seems like a good deal to me. Now, if you use this panel, you'll see that this script doesn't have a name yet. If I go ahead and save this scene, Godot will give it a name to identify it as a resource, which is not human readable. So for built-in scripts, it's a good idea to give it a name in the inspector. I'll name it btn instructions. Save the scene, and there we have it. So I'm going to get rid of what we don't need. And what we want to do is change the verse state every time we press this button. And this node already comes with a signal that gets triggered when the button is pressed. So I'm going to connect the signal pressed to this self node to the function onPressed, which we are going to create here. So in this function we're going to get the var with utils.getMainNode getNodeBird. And if we found it, we'll say bird.setState bird.stateFlappy. And then we're going to hide this button. Let's try it out. And when I press somewhere in the screen, the bird goes to the flapping state. And if you really pay attention, you'll see that the bird is not rotating around its center. It has a little offset. And what's happened is that in the flying animation, we are moving the sprite up and down. So when we shift on the state, it might not be a 0-0. And there are a lot of ways we can solve this. We can play the idle animation when we exit the flying state, or we can just stop the animation and set the position of the sprite to 0-0, which is what I'll do. So in the exit function of the flying state, bird.getNode anim.stop, and then bird.getNode animSprite.setPosition, and pass a vector 2 with a value of 0-0, and it should be working now. Now there is one thing that bothers me, and to press the button we have to press the left button of the mouse and then release it, which doesn't feel right on this game, and you'll feel even worse on a phone. So to fix this, in the btn instructions, we'll enable click on press. And now I just need to press and the action will perform. And since we are also using the keyboard in this game, I would expect to press space to start the game, since we can also flap by pressing this key. Fortunately in Godot, when a button is focused, we can press it by pressing enter or space. So in the button script, we're going to call the function grabFocus. And of course we won't be able to see it because we don't have any texture in this button. But if we run the game, if I press space, the button gets pressed. Now the bird is starting 2 at the top of the view. So in the bird scene, I'll set its position to 120. And there is one more thing. Having the bird falling when the gameplay starts doesn't feel quite right. So when the bird goes to the flapping state, we're going to call the function flap. And now it feels way much better. So the next thing is to start the spawner pipe when the bird starts flapping. And in order to let other nodes know when the bird changes its state, in the bird script we're going to create a signal named StateChanged. And we will emit it in the setState function. And we do want to send some extra information. We will send the bird itself, because other node connected to this signal will surely want to know the state of the bird, or just get some information about the bird. So now that we have that, in the spawner pipe script, in the ready function, we're going to look for the bird. And if we found it, from the bird we'll connect the signal StateChanged. Here in the spawner pipe, to the function onBirdStateChanged. which we will create here. And let's not forget that this signal is sending us the bird. So now we will ask if bird.getState is equals to bird.stateFlappy. And if it's so, we will call the function start. Now every time the bird changes its state, this function is going to get called, and if the state is flapping, it's going to call start again. But we just want this to happen once, and it's going to happen once, because in the game stage, the bird is only going to change to flapping once. But just in case, in the connect function, besides of the signal, the target and the function, we can also send some extra data from here in an array, which we won't do, so I'm just going to pass an empty array. And also we can set a flag, and we're interested on this one, connect one shot. So this function is only going to get called the first time the signal is emitted. Let's run the game. And when we start flapping, the spawner pipe starts, but it doesn't start in the right place. And the problem is that in the GoInItPosition function, we are setting the x value from 0 plus the view width plus half of the pipe width. So our initial position is always right here, and since the bird is moving while flying, the camera might be way off from the origin. So we just have to consider the position of the camera. So back to the spawner pipe script. In the GoInItPosition function, we're going to get the camera using the utils function. And if we have it, we will increase the initPosition.x by the camera total position x. Let's give it a shot. And now it starts spawning in the right place. So now we need to make a transition for the hit state, that is when the bell hits a pipe, and also a transition for the ground state, that is when the bell hits the ground. And to do so, we're going to detect collisions. So in the rigid body of the bird, we're going to enable contact monitor and increase contacts reported to 1. And the rigid body will let us know when the collision happens through a signal. We're going to connect the signal body enter to this self node, to the function on body enter, which I will create below the input callback. And this function is going to give us the other object the bird has collided with. So we need to have a parameter which I will name other body. And the bird won't do anything in this function, it's just going to delegate it to the current state. Now not all the states will care about collisions, so we won't create that function in all the states classes. So I will ask if the state has a method on body enter. And if it's so, it will call the function. So again, we could have easily get around this if we were using a parent class and inheritance with the states. So yeah. Anyways, in the flapping state, we will have the function on body enter. And here, depending if the bird has collided with a pipe or a ground, we will change the state to hit or grounded. And to know with which one the bird has collided, we will use groups. So in the pipe script, in the ready function, we're going to call the function add to group. And this function is just asking for the name of the group. I'm just going to pass pipes. Now I don't really like having the groups like this. I mean, I prefer to have all the groups somewhere rather than just a simple string in here, which isn't bad at all, but this really bugs me. So I'm going to create a script by going to File, then New. I'll save it in the scripts folder under the name game.gd. And notice that by creating this script in this way, it's not going to be attached to any node. And I did it like this because we can actually set a script as global and Godot will create the node for us. So this script is going to be attached to the kind of node it's extending. In this case, it's just a simple node. So let's go to the project settings and under auto load, we'll add the game script. Now, when we created the util script, we actually created a scene utils to have the script. So since there is no actually need to do that, I'm going to delete it and add the util script instead. And since we have it under the same name, it won't give us any errors. And let's go ahead and delete the util scenes because we don't need it to hold the script anymore. Now we are in the game script. I will clean this up. And here we will create two constants named group pipes equals to pipes and group grounds equals to grounds. So back to the pipe script, we will say instead game.groupPipes, and in the ground script we will say add to group game.groupGrounds. And back to the Flappy state, if the other body is in the group game.groundPipes, we will set the state to hit. Otherwise, if the other body is in game.groupGrounds, we will set the state to grounded. Let's run the game to see what we have. And when the bell hits a pipe, we no longer can flap, because that is only available in the flapping state, so everything is cool. So we are now going to take care of the hit state. And this is what is going to happen once the bell hits a pipe. We are going to stop moving, so the gravity makes the bell fall right away. Also, we will make the bell rotate clockwise, so it faces down while it's falling. And the bell has to stop colliding with the pipe it hit, so we can go through it to the ground. So in the hit state, we are going to set the linear velocity to 0 in both axes, so it stops moving. And also we will set the angular velocity to 2, so it faces down while it's falling. And to have the bell not colliding with the pipe it hits, we are going to get the colliding bodies, and that gives us an array. We will take the one in the index 0, because we are just going to get reported about one collision anyways, as we specified before. Let's graph a reference on a variable named other body. And finally we will say bird.add collision section with other body. Let's give it a shot. And there we have it. Now for the ground state, we just want the bell to stay put. So we just need to set the linear velocity to 0. As well for the angular velocity. Let's try it out. And it doesn't move. Now if we hit a pipe, we can see that the bird keeps moving when it is in the ground, and that is because we don't have a transition from the hit state to the ground state. So in the hit state we will have the function on body enter. And we will ask if the other body is in the grounds group. And if it's so, we're going to set the bird state to grounded. Let's see if it's working. And there we have it. Well, this is gonna be it for now. Like this video if you enjoy it, and subscribe for future ones. And until next time, see you later.